Hey everyone, and welcome to The Explainer. Today, we're diving into a truly fascinating structural framework uncovered from some incredibly detailed architectural blueprints. We're going to be exploring a concept called Green OS. It's essentially an artificial intelligence operating system built completely from the ground up for green building and sustainable infrastructure. If you've ever found yourself wondering how the massive physical structures around us might one day actually think and optimize themselves to save energy and slash emissions, well, you are in the exact right place. So, think about it. How do we actually build truly intelligent, zero-carbon cities? Well, right now, we've got a massive problem. The architecture, engineering, and construction industries are historically super fragmented. You've got architects designing the space, engineers calculating loads, sustainability consultants checking compliance, and facility managers just trying to keep the lights on. And the kicker? They're often all using completely different software that absolutely refuses to speak to one another. So how do we build the cities of the future when the very process of building them is so disconnected? Okay, let's dive into this. The real core of the problem is total isolation. Right now, traditional building management relies on completely disconnected data silos. If there is a change in an architectural plan, it doesn't automatically update the operational carbon footprint in real time. It doesn't instantly flag a safety compliance issue for the site manager. But what this source material proposes is a total shift to a cohesive AI ecosystem. Imagine a system where literally every piece of data, from the weather outside to the HVAC system inside, is constantly talking and optimizing itself automatically. It's a total game changer. So here's our roadmap for today. First, the Green Building Challenge. Second, meet the Green OS. Third, the Master Orchestrator. Fourth, the specialized AI agents. Fifth, following the data flow. And finally, a sustainable future. And don't worry about getting bogged down in the tech, because we're going to view this whole incredibly dense system through one super simple metaphor, a massive symphony orchestra. All right, jumping right into part one, the Green Building Challenge. Setting the stage here. Managing all this data, running deep climate analysis, and ensuring strict environmental compliance requires a completely new structural paradigm. You simply can't just toss a basic chatbot at a commercial skyscraper and expect it to run an electrical grid, right? Now, what's really interesting about this architecture is the sheer, uncompromising scale of the whole shebang. On one side, you've got your massive data sources and inputs, like 3D building models, IoT sensors, and live weather APIs. And on the other side, a vast array of external systems and heavy-duty cloud servers. And right there in the middle sits the Green OS. It acts as the ultimate translator, connecting the human stakeholders up top, the architects and the owners, with the actual physical real-world outcomes at the bottom, like energy-efficient designs and predictive maintenance. Moving on to part two, meet the Green OS. Let's shift from that huge architecture overview and break down the actual operating system stack itself. So, if we peel this system back layer by layer, starting from the top down, we can clearly see exactly how humans interact with all this deep technical infrastructure. At the very top, you have the users and stakeholders. They tap into the system through the access layer, which is basically the digital front door. Think web dashboards, voice assistants, or even an augmented reality digital twin. Right beneath that is the absolute heart of the system, the AI agents layer. That is the true brains of the operation. Supporting those agents are the core platform services handling the logic. And finally, sitting at the bottom carrying the weight of it all is the infrastructure layer, the actual cloud servers crunching the numbers. Which brings us to part three, the Master Orchestrator. Because, every great orchestra absolutely needs a conductor to keep things moving. And this brilliantly illustrates how that conductor sits right at the top center of the hierarchy. The Master Orchestrator agent is positioned directly beneath the human users and their access channels. It bridges those human interfaces with the incredibly complex backend. So when a facility manager types a quick query into their dashboard or talks to their voice assistant, they aren't just talking to some dumb database. They are talking directly to this orchestrator. It is literally the executive brain of the whole setup. Its role is simple to explain, but massive in scale. It plans out workflows, delegates tasks to the right sub-agents, monitors their progress, and constantly optimizes operations. And it doesn't just guess. The orchestrator makes its decisions based on project memory, established compliance policies, the specific goals of that building, and the real-time context of the situation. It received a command, breaks it down into a bulletproof strategy, and seamlessly passes the baton. All right, part four, the specialized AI agents. If our orchestrator is the conductor, these agents are the individual master musicians in our orchestra, and each one plays a very specific, vital instrument. Get this. This entire ecosystem is powered by an astonishing 28 distinct, highly specialized AI agents. We are not talking about one giant, clumsy AI trying to know and do absolutely everything. It is a thriving, dynamic ecosystem of 28 separate experts working together in perfect tandem. So, the crucial point is how we can group these agents functionally to understand their true value. Over in design and planning, you have specialized agents handling complex 3D BIM coordination and calculating material quantities. In compliance and legal, you've got agents totally dedicated to making sure you pass strict environmental codes, like ECBC and EDGE certifications. And in operations, agents are tracking live IoT sensor data and scheduling predictive maintenance. Literally everything, from structural load analysis to analyzing drone footage of a construction site, is handled by a dedicated, specialized expert. But wait, how do 28 different AI agents avoid just constantly stepping on each other's toes? Well, they rely on a shared intelligence layer. This is the shared sheet music for our orchestra. It includes a knowledge graph, a project database, vector DB, AI memory, a continuous learning engine, and a core rules and policies engine. Because they all draw from this exact same shared intelligence, an architectural design agent is never going to suggest a floor plan that the safety compliance agent will later flag as illegal. They're continuously learning and staying perfectly aligned on both the rules and the project's history. Moving to part 5, following the data flow. Understanding the agents conceptually is one thing, but seeing exactly how this massive system reacts to a single real-world event, that's where the true power of this architecture really shines. Let's track a single event step by step to see this in action. Say a conference room gets way too hot. That sensor event triggers a webhook, which is basically an instant digital tap on the shoulder. The master orchestrator catches that alert, processes it, and immediately calls on the relevant specialized agents. Maybe it brings in the IoT monitoring agent and the energy optimization agent. Those agents quickly communicate with the external systems to physically adjust the HVAC load. An actual real-world action is taken. Finally, all of that data is stored right back into the shared memory, and the facility manager's dashboard is instantly updated. It is a completely closed, hyper-intelligent loop. Finally, part 6, a sustainable future. Because the whole purpose of analyzing all these complex data flows isn't just for the sake of looking at cool technology. It's about the tangible, real-world impact. The final payoffs detailed in our source diagrams translate to immense environmental and financial gains. We are talking about truly energy-efficient buildings with a drastically lower carbon footprint, both in construction and operation. This level of orchestration leads to massive cost savings, flawless automated compliance with green building standards, perfectly smart operations, and ultimately much healthier, more comfortable environments for the people actually living and working inside these structures. By ditching the fragmented software silos of the past and going all in on a multi-agent AI ecosystem, the physical infrastructure of tomorrow becomes adaptable, self-optimizing, and profoundly sustainable. It all brings us perfectly to the core philosophy driving this entire framework. One platform, many agents, endless intelligence. This framework completely reframes how we view the spaces we inhabit every single day. And it leaves us with an incredibly compelling question to chew on as we wrap up this explainer. If your building could think, what would it solve first? Thank you so much for exploring the Green OS with me today. Keep asking great questions, and I'll see you next time.